Okay, so today's lesson is on scatter plots and linear regression. So these are all of the topics that we have covered so far. Measures of center are mean, median, and mode. So go ahead and rate your understanding. Red meaning you're not sure what those are. Green meaning you're okay. Measures of spread would be things like standard deviation. Box and whisker plots, the 5-number summary. Do you know how to graph a box and whisker plot? Rate yourself. Normal distribution is the bell-shaped curve, being able to label the numbers underneath the curve, and then using the empirical rule, which is 68, 95, 99.7 to find the area under the curve. Z-scores would be the same thing. You're finding partial standard deviations and putting those numbers into your calculator to find area under the curve. And then number 6, using the normal CDF, percentage under the curve. Go ahead and rate yourself. These are all topics that are going to be on the test. Anything that you have circled in red, you can easily go back and find the videos before you take the test. The test is coming up either Friday or on Monday, depending what section you're in. And these are all test questions or test topics. So this is our topic for today. We're doing scatter plots and correlation coefficients. These are all scatter plots. A scatter plot is a set of points plotted on a horizontal and vertical axis. Scatter plots are important in stats because they can show the extent of a correlation, if any, between the variables. So positive correlation means that as your x's are getting bigger, your y's are getting bigger. So it has a positive slope. Negative correlation, as your x's are getting bigger, your y's are getting smaller. So it's going down as you read it from left to right. No correlation. If I were to draw a line through this, it wouldn't really predict the data. The data isn't going up or down. It's kind of all over the place. Okay. A trend line on a scatter plot shows correlation more clearly. So here's a trend line or a linear regression line. We are using something called the correlation coefficient R to measure strength and direction of the linear relationship. So R is between -1 and 1. You get it from your graphing calculator. A -1 shows negative correlation. A +1 shows positive correlation. And you can have a number anywhere in between -1 and 1. So -1 means all of your points land exactly on that line. +1 means all of your points land exactly on that line. If you had a positive 0.9, it might look something like that. Something where some points aren't on the line, but it's clearly showing the trend. Whereas a negative 0.8, and most of your points are close to the line or on the line, but not quite a perfect negative correlation. And then a correlation of 0 means there's no relationship between the variables. Again, there's no trend. It's not going up, it's not going down. There's just no relationship. So like I said, the correlation coefficient you're going to get from your calculator, anything that's from 0.9 to 1, that's very high and positive. But really, I'm going to circle the 0.7 to 0.9. All of those numbers mean high to very high. Moderate is 0.5 to 0.7. And low to not really much would be 0.3, 0 to 0.3. Do you have to memorize that? No. But you'll be able to see from the data. Here's a negative 0.9. If I drew a line, I'd catch most of those points. Negative 0.5. It's clearly negative, but it's not necessarily, the points aren't very close to the line compared to the first box. And you can see there's no, in the last box, there's no positive or negative correlation. Okay, moving on, 0.5 positive. It's going up, but lots of the points don't actually touch my linear regression model. 0.9, most of the points, it's very close to 1, which is a perfect correlation. 0.9 is positive, very strong correlation. And then here's 1. Every point is on that line. So we're going to look at this data and describe the correlation. I would say the first one, there is no correlation. which means the strength is weak. I'm actually not going to talk about the strength because if there's no correlation, then there can't be strength. I'm going to say that this one's positive, and this one's positive, and this one's negative, and this one's negative. Now let's talk about which one is the strongest. I would say of all of these, this guy has a strong negative correlation. As you draw the line, it catches most of the points. You could probably argue that this one has a strong positive correlation, and that this one might have a moderate negative correlation, and that maybe this one has a moderate to weak. I would take either of those answers. Okay, what do I do now? Okay, so to get R in your graphing calculator, you won't be able to get this unless you go through this process. So first you have to push catalog, which means you push second and 0 on your calculator. It accesses the entire catalog on your calculator. You want to go all the way down, hit the down arrow on your calculator. It's going to take a second to get down to the D's. You're going to look for this, diagnostic on. Enter, enter. It will say done. There. When it says done, then your diagnostic is on. Now when you do one variable stats and you look for the linear regression model, your R will show up. Your correlation coefficient will show up, but it won't without going through that process. Now we're going to take some data. We've got weight versus max speed. We're going to make a scatter plot. We're going to find the correlation coefficient using our calculator, and we're going to find the line of best fit. Line of best fit is in y equals mx plus b. We're going to find the slope, and we're going to find the y-intercept using our graphing calculator that fits this data the best. So first we have the scatter plot. We've got weight versus max speed. It's already been plotted out. You can see already that it's probably going to have a negative correlation coefficient, and the slope of the linear regression line is going to be negative. To put this in your calculator, we've already been in these sections of our calculator before, so you're going to hit the stat button, and you're going to fill out list 1 and list 2. Here's list 1, here's list 2. So go ahead and pause this video so you can add list 1 and list 2 in. And then you are going to go into the calc menu. Now, before we've done this one variable stats, I'd like you to bypass that and go into option 4, which is linear regression. Instead of mx plus b, it's ax plus b, but it's the same thing. Hit enter, and then enter, as you can see, enter through the rest of the options. You will be given mx plus b. Forget about r squared. There's your correlation coefficient. So you would say y equals negative 0.309, maybe, x plus 49.13. That would be, or you could say y equals negative 0.31 x plus 49.13. If you were to graph that line through these points, you would get something that looks like that. The correlation coefficient of negative 0.1 means that there is a negative relationship with the data and that it's strong. Negative correlation coefficient. So this is our last problem. We have an athlete or different athletes of different ages and how far they can throw. So our line of best fit, I've already put in this data. I get y equals 3.11 x plus, actually, minus 16.89. Using our line of best fit, estimate how far a person can throw if they are 17 years old. That means x equals 17. So you're going to substitute x for 17 to find how far the person can throw. I just input the data into my calculator, and I have 35.98 meters. Using your line of best fit, estimate how old a person needs to be if they can throw 50 meters. This is a y value, so you'll have to solve backwards. So that means that 50 equals 3.11x minus 16.89. And we're going to do a little algebra to solve this. So add the 16.89, you get 66.89 equals 3.11x. And we're going to divide 16.89 by 3.11. And we end up with 21.5, so 21 and a half years old. There is a short video that shows how to put all of this into your calculator. Following this, if you haven't picked it up from the other lesson, it's about 5 minutes. If you need a little refresher on your graphing calc, that is after this video. Okay, this last question is on your own. Pause your video, try the problem, check your work. We'll be back in a second. Okay, after you unpause your video, you should have these values. So here's my line of best fit with a 0.97 correlation coefficient, which is a strong positive correlation. Once I plug in my x value, I end up with 58.63 inches tall. And then when I plug in 65 inches for my y value, my x value is 17.6 years old. So you're a little different today. Our discussion board for attendance, so you can kind of synthesize what's happened in this lesson. And then we have a PDF worksheet for the formative. I will be on Google Meet if you have any questions at Elizabeth Eichler. Otherwise, have a good day.